Okay, today we will be solving this question, question E, from my trigonometry challenge. First, we have these two formulas. They show the central angle in terms of arc length and radius. And the first one is in radians, and the second one would be in degrees. Okay, so first we will solve for the central angle in radians. So we'll be using this first formula here. So I'm just going to move it down to here and we can work on it. So first we can find that the radius equals 4 and the arc length is 9, both in centimeters. And now we will just plug those numbers into the formula and solve for theta, which in this case is the central angle here in radians. Okay, so now we'll just plug this in. So arc length, which is 9, equals theta, times radius, which is 4. Okay, so now we will solve for theta. So to solve for theta, we will set everything in terms of theta, and we will do that by dividing both sides by 4. And we do this because we're using multiplication here, so we're dividing both sides to get rid of that 4 on this side. So then, if we divide 9 by 4, then that is 9 over 4. So, the central angle of this circle here, of this section, is 9 over 4 in radians. Now we will calculate it in degrees. So to do that, we will use the second formula that I have here. And we have these measurements here. They will be the same because we're using the same circle. We're just changing we're just changing it from radians to degrees. So now we will plug it in just the same as the other one. And the radius is 4, so it goes right here. All right, so now this one's a little bit more difficult to solve for theta because theta is in a fraction. So to do that, first, we'll divide both sides by 2 pi 4. All right, so you can see, just like the other one, this one here cancels out because this just equals 1. So you can get rid of that. So before we calculate what this exact number is, I'm just going to multiply both sides by 360 so we can get theta alone on that side. So do this. All right, just like that. So here we have everything in terms of theta. So this is the value of theta in degrees, but we're now just going to have to plug that into a calculator to get a number amount. All right, so after calculating all of this, plugging it into a calculator, we get 128.92 is equal to theta. So that is the value of the central angle of this circle in degrees. And that's it.